But first, we'd like to understand a bit about the louvers themselves. For example, how big are they? Let's just think about their length. You know, from one end to the other of each one of these individual louvers, each one of the flaps that moves up and down. And we would like to use some mathematics to help us understand them. So how long do you think they are? We might start by guessing. How long do people think those louvers are? Just take a look up there and kind of guess.
20 feet.
I hear 25 feet, I hear 20 feet. Okay, fine. But we want to try to be able to do better. So I brought a tape measure. And unfortunately, although I am wired for sound, it doesn't quite give me the ability to fly up there and put the tape measure across one of those louvers. You know, we can't get up there, but how can we measure that louver exactly?
Use the windows. Measure the windows.
Okay, so we want to have them stand underneath the ends of the louvers. And why will that be useful?
From here, start and the end.
Yeah, right. So what we're actually relying on when we do that is, you know, whenever you're going to do math, you should have a whiteboard with you. What we're relying on for that is that we're going to create a particular shape, and we're going to use the mathematical properties of that shape to help us do the measurement. So here's the louver, way up here in the air, okay? And here we are on the ground, and we would like a line that has the same length on the ground that we could actually measure. So what shape would we like to make out of this, that we're going to be able to have that property? A quadrilateral. So will any quadrilateral do? Will I be able to? No, I need a special kind of quadrilateral. What do I need? Yeah, right, exactly. So actually any parallelogram would be good enough, because a parallelogram has the property that opposite sides are equal. But what's the most convenient parallelogram for us to make? The most convenient kind of parallelogram for us to make? A rectangle. So what we'd like to do is make this into a rectangle, so we can find these 2 points. We'll measure the distance here, and that'll give us the length of the louver up above. Okay, fine. How are we going to be sure that we're right underneath the end of the louver? What can we do down here on the ground that's going to make us certain that we're underneath the louver? Yeah, exactly. We can actually see right here at the base of the building where in fact, here's our rectangle right here on the building that we're going to use. And so we can see that this seam in the concrete blocks, and over there, that seam over there, not the nearest seam, but one farther over, that's exactly the length of those louvers up there. And so now we can just measure it right on the ground. And if I have a friend to help me, somebody. Here we go, thank you. So we're gonna go right from that seam, and I tell you what, we're gonna assume they made the blocks the same length, and we'll just measure one block. So get that right down onto the block, and here we go, and it's 14 feet. And so how long is each louver?
28.
28 feet, so actually your estimates are pretty good, well done. All right, so now we have a sense for the louvers. They're each 28 feet.